Hey everybody, welcome to Schizophrenia Day 2. So this is the final lecture. So congratulations, you've made it through the course. Well, when you make it through today, and we've covered quite a bit of things, from depression to the synaptic mechanisms of neurotransmitter release, receptors, psychedelics, all sorts of fun stuff. So today, we're going to finalize our work on schizophrenia. Mostly I'm going to go over these four things. So review kind of how over time, if you have schizophrenia, how does it evolve as you're developing? I want to mention something that wasn't really talked about in the book, and that's the extreme suicide risk associated with schizophrenia, because I think it's pretty serious to consider. And then we'll dive into some of the theories of how it is produced, at least in the brain. And I've touched on a little bit about those already with discussion of dopamine involvement. And then we'll dive into the medications that are used for treating schizophrenia. Okay. Okay, how does schizophrenia progress over time? Well, there's this kind of series of components to development of schizophrenia. I talked a little bit about that last time as well. But one, there's a very big genetic component. For example, if you're an identical twin, there's a 50-50 chance that you're going to get schizophrenia. The chance in the general population is around 1%. So 50-50 if, let's say, your twin brother or sister happens to be schizophrenic. Now, that's not just genetics alone, though. Environmental issues, as in chemicals in the environment, having a virus, maybe when you're developing in the womb, toxins, nutrition, birth complications, they can also influence your likelihood of developing schizophrenia, usually much later in life, like in your teens, 30s, or even later. Later on, though, there might be other issues about synaptic development, so how your synapses develop, and that could even happen after you're born. So I talked a bit about this pruning hypothesis, that maybe everything's going all right over time, but the mechanisms in your brain that tell your brain to stop pruning the synapses don't work anymore. So your brain keeps pruning synapses throughout life. And I mentioned too, or reminded us that microglia are involved in synaptic pruning. Other things can go on too, that can happen during the early stage of development, and how your neurons are formed and how they migrate, which means how they move from one location of the brain to where they're going to ultimately live for the rest of their lives, how they move to different anatomical regions of your brain. Apoptosis is just how neurons die. It's just the rate of apoptosis, or programmed cell death, and apoptosis just means cell death. So all these things can change at this early stage of development, both pre and around the time of birth. All right, so then at the latent stage, this might be for your average condition. Again, it differs from males and females a bit here, but let's just say in your teens area, there might be subtle signs. So just from behavior alone, it's often impossible to predict whether somebody's going to ultimately develop schizophrenia by just looking at their behaviors in their teens. It usually takes until they really get into their 20s or so before the behaviors are so severe that you can clearly see that they have schizophrenia. But there are some hints. So example, in these teen years, you might have motor abnormalities. They might be very apathetic. They're just not interested in having emotional contact. They withdraw socially, and they might have some deficits in attention and just general information processing tasks. And then at the late stages, that's when that synaptic pruning thing really its toll has really started to come into play, is that years of continual synaptic pruning has left good chunks of the brain with fewer synapses than it should have. And then that could lead to very strange connectivity between brain regions, might reduce connectivity to the frontal cortex. I mentioned that the frontal cortex activity is lower. You get this environmental dependency syndrome if you have low frontal cortex activity. I mentioned last time. And also at the late stage, this is something similar to what we talked about with stress and depression, is that if you have stresses later in life, it might contribute to the sudden onset of schizophrenia. So later environmental insults. So just like you have those prenatal environmental insults that can potentially trigger the genetic or epigenetic factors that could lead to schizophrenia, later in life, these similar, perhaps like stress and things like that, and insults in the environment might also trigger schizophrenia. I also should mention too, just to remind the connection with marijuana use, that potentially teen or even later high use of marijuana is correlated at least with the onset of your first full-blown schizophrenic episode. All right, and as things go on throughout the rest of your life, which could be quite a long life, you could have a growing impairment in general cognitive function, such as attention deficit issues, memory issues, decision-making, executive function issues. Then you get the nasty things like the delusions and the hallucinations, these really negative thought patterns. And then also, those are the positive symptoms. And then you have those negative symptoms too, which are things that are they look like depression, this inability to derive pleasure, isolation, the lack of willingness just to move or do anything. So that kind of gets worse and worse typically over time if schizophrenia goes untreated. And today we'll talk a lot about the treatments, at least about some of the pharmacological treatments. All right. And as I suggested, there is one important thing that is associated with schizophrenia that I think should be pointed out, is that it's a very serious disorder in the sense that it is extremely likely, relative to pretty much any other disorder, to result in the patient attempting or actually committing suicide. And you might be able to have some idea as to why, or be sympathetic. I mean, here you have a condition where you've just fractured your mind. You don't even know who or what you are anymore. You don't have control over your own thoughts. You're hearing voices that you know aren't real. Maybe they're telling you very negative, hateful things all day long. What do? You're kind of trapped in your own mind. And so I guess you can see why that can be so debilitating and increase the risk for suicide. So this figure is just crazy. 30% of people diagnosed with schizophrenia, at least at one point in their life, attempt suicide, and 9% actually complete the act. And this is much larger than the general population. Now this risk here can definitely be reduced a lot, like by 50%, if there's been a consistent medical, or in this case pharmacological treatment is prescribed. If they're taking their clozapine or chlorpromazine, we'll talk about those drugs in a minute. If they're taking the drugs, well, then the risk is much less. And so that just emphasizes the importance of being disciplined, if you have schizophrenia, about taking the medications, which can be difficult because these medications have side effects. All right, mechanisms. What is going on in the brain in schizophrenia? We talked a little bit about this pruning idea, which I think is really neat, and about the role of dopamine potentially and glutamate. But I just want to go a little bit more carefully into some of the theories just to lay them out. All right, and I will categorize these theories into three general groups. The general dopamine hypothesis, which just means there's just too much dopamine overall in your brain, so that's a problem. All right. Then we have the dopamine imbalance hypothesis, which is essentially just putting a little nuance on the dopamine hypothesis, saying that it's not just too much dopamine, it's an imbalance. You've got too much into areas like your nucleus accumbens, too little in your frontal cortex, and this imbalance is screwing you up. And then we have a third one, which is kind of a mixture of number two as well, but combining glutamate, or the lack of glutamate, and that is the hypoglutamate hypothesis plus dopamine. And so yes, they say there's a dopamine imbalance, but it's also due to this low frontal cortex activity that's associated with not having enough glutamate transmission going on in the frontal cortex. So too little glutamate, and especially in the frontal cortex. The first theory regarding the neural mechanisms of schizophrenia will go again as the dopamine hypothesis. It's the simplest theory. It's just saying that there's an imbalance in the brain, and essentially what it's causing is that overall, throughout your entire brain, there's just too much dopamine getting released. And that causes all of these problems. And what is the evidence for this general theory of too much dopamine in your brain? Well, one is that if you, or if you're a drug abuser, take a heck of a lot of amphetamines or cocaine, you see symptoms, even in a healthy person, that are very, very similar to schizophrenia. And so that's one point of evidence. And if you give these same drugs to a schizophrenic, it can worsen their symptoms. And when I say symptoms, pretty much I'm just referring to the positive symptoms in schizophrenia, the hallucinations, the delusions, those types of things, not the negative symptoms. And then if you give, for example, somebody even who does not have schizophrenia and who has taken a bunch of, let's say, cocaine, and they're exhibiting all these crazy delusional episodes, you can get those delusions to reduce if you give them a classic antipsychotic medication. So one of these drugs that blocks D2 receptors that works fairly well for treating schizophrenia. So that's more evidence that dopamine is somehow involved. And the other point of evidence is that of the whole, and there's I don't know, 30 drugs or so that are out there for treating schizophrenia. And the vast majority of them, if not all of them, work in some way on the D2 receptor. And the clinical efficacy of the drugs is almost perfectly correlated with that particular drug's affinity for the D2 receptor. By affinity, I mean how well it binds to the D2 receptor. All right, so all these things point to it. And there's even more evidence. There's evidence from PET studies, positron emission tomography, that suggests that there are more D2 receptors in people with schizophrenia. Okay, what is this PET thing I mentioned here? All right, so PET, again, positron emission tomography, it's a very handy way to essentially convince somebody to inject themselves with a radioactive element that will then reduce high energy particles from your brain. And I'm not kidding, this is what you do. You inject this radioactive element into a human, a healthy human or a schizophrenic human in this case, or addicted or whatever you're studying. And then whatever you injected, you make it in such a way that it binds, for example, to a particular thing you're interested in. Let's say you make it have an antibody, or some way you make it so that it gloms on to, let's say, a D2 receptor or a D1 receptor. And so it allows you to determine the relative concentrations of these receptors in the brain. But you can also get it so that it can measure glutamate utilization in a brain, so metabolic activity in a brain too. So there are many ways you can use PET imaging. But yeah, it basically boils down to using radioactive tracers injected into the blood and then see what things they bind to in the brain and then emit the radiation. And then you have this big detector, you can detect how it's imaging. That's what I'm showing with that image I'll put the pointer on. It's an image up in the upper left here. That's an example of a PET study. It looks like they're looking at something binding here to the striatum, the basal ganglia. That's where this area is that's lighting up here. So this is an example. All right, so going back to this, is that PET studies show that there are more D2 receptors overall in patients with schizophrenia who haven't been taking medications. And that's also correlated with their degree of their positive symptoms. So this whole D2 receptor positive symptom connection is really strong. So one idea is connecting this with this too much dopamine hypothesis is that we've learned before that the brain is very good at trying to get back to normal. If there's too much glutamate, maybe it'll try to find a way to reduce glutamate release. If there's too much, in this case, dopamine, it's going to find a way potentially to reduce the dopamine release, or at least the amount of binding the dopamine does with postsynaptic receptors. Well, let's talk about the release. If we remember that these D2 receptors, again, are autoreceptors, and generally autoreceptors tend to decrease synaptic release because they're on the presynaptic terminal. If your brain is generating more of these things, basically I think it's letting that system be better at shutting down dopamine release. So it might be an adaptive function that's going on here that we're witnessing with this increase in D2 receptors. Okay, well, I guess I can leave that at that. All right, so now moving forward to the dopamine imbalance hypothesis. It's a nice mixture, or more of a let's say a subtle or nuanced version of the dopamine hypothesis. And so you might think that the general dopamine hypothesis is a little bit crude. It just says there's just too much dopamine. And that really doesn't get at a lot of the subtleties of the deficits in these patients. And so other evidence suggests it's not just too much dopamine, it's too much dopamine in regions of the brain like the nucleus accumbens. It's too little dopamine and too little activity in general in regions like the prefrontal cortex, which could explain maybe some of the negative symptoms of schizophrenia. So it's not just overall too much or too little, it's where the dopamine happens to be. And so there's some evidence for this imbalance idea, that there's reduced dopamine in mesocortical areas. By that I generally mean areas that receive dopaminergic input, like the prefrontal cortex and motor cortex, by the way, but I'll focus here on the prefrontal cortex. And so low prefrontal cortex, again, activity might result in a lot of these cognitive and executive function deficits you see in schizophrenics, but also may contribute to the negative symptoms that are more similar to depression. But there is strong evidence, completely in contrast to the frontal cortex, that there's actually increased dopamine in mesolimbic areas, which are areas like the nucleus accumbens area we've talked about a lot, especially in the context of addiction. And so that might be more responsible for the positive symptoms of schizophrenia, like the delusions and hallucinations. All right, so this is another dopamine-connected disorder. But the other dopamine-connected disorder that we've talked a great deal about, the developmental disorder, is Parkinson's disease. And so just as a thought question, maybe compare in your heads what you think are the differences, or how are these two hypotheses different from the hypotheses about how Parkinson's disease is generated, or how dopamine is involved in Parkinson's disease. All right, moving on from dopamine. So there are some theories that other neurotransmitters are involved here, with the primary one being glutamate, the primary excitatory neurotransmitter in your brain. Most neurons in the brain, that's the transmitter, and that's the transmitter that can rapidly excite other neurons. All right. So what's the evidence for that? Well, one is that PCP, or angel dust, or ketamine, both of them are NMDA receptor antagonists. They both also produce symptoms in healthy and exacerbate symptoms in schizophrenic patients that are very similar to the positive symptoms. So again, these hallucinations, these delusions and things like that. So it suggests that these receptors and at least glutamate transmission in the brain is somehow screwed up in schizophrenia. And in particular, the idea is that glutamate transmission and general levels of activity of glutamate release in general is reduced in the prefrontal cortex in schizophrenia. And that may, like I suggested previously, contribute to the cognitive and the negative effects associated with schizophrenia. So that's where the final idea comes in. Oh, okay, sorry, just put this up here. This is just an image of hypofrontality I mentioned in the previous lecture, where you have the frontal cortex getting less activated. All right, this hypoglutamatergic hypothesis plus dopamine imbalance hypothesis get merged here in theory 3, and in that you have less glutamate in the prefrontal cortex, less activity in the prefrontal cortex, which you've already seen. You got this low level of frontal cortex activity, maybe explaining the executive function issues and the negative symptoms. And you also get less dopamine released to the frontal cortex. So everything goes down in the frontal cortex, glutamate and dopamine, but you get more dopamine release in the nucleus accumbens. And that's these four things come together, and those are what really drive the symptoms of schizophrenia. And as I mentioned, this NMDA, drugs that block NMDA tend to produce, and since that's a major glutamate receptor in the brain, tend to produce symptoms like schizophrenia, and there's reduced activity in the frontal cortex overall. So that's the third hypothesis about how schizophrenia is generated in brain circuits and neuromodulator and neurotransmitter release. Okay, with that is the end of part 1. Now on to part 2.